So welcome to section 5.5.1, absolute value transformation. Today we're going to focus more into dilation. So there are going to be two types of dilation. On the left, we have the vertical dilation, and on the right, we have the horizontal dilation. So let's take a look at vertical dilation. Vertical dilation will have the form of f of x equal a times absolute value of x. So a is a number that's going to be outside of the function or outside the absolute value lines. Now for vertical, there's two types. There's going to be a vertical stretch and a vertical compress. Now to classify as a vertical stretch is when you have the absolute value of a, or purely the number value of a that is greater than 1. Now the reason it's written as the absolute value of a is because you want to only focus on the number value. Now in the previous section, we worked with reflection, and reflection involves with the negative sign. So in the event that you have a problem or an example where there's a negative sign in front of a, and if you're just focused on dilation, then you're just going to look at the number and ignore the negative sign. So if the number value is greater than 1, you can classify as vertical stretch. Now to classify as a vertical compress is if the a value is between 0 and 1. Now let's look at horizontal. Now the form for horizontal dilation is the f of x equal the absolute value of b times x. So in here, for horizontal, the number value of b is located inside the absolute value lines, but it's in front of x. The reason I want to point out that b is in front of x is because when we went over translation, now if you have a number with the x inside, it translates left or right. But to be specific, for translation, the number is behind the x. Now for horizontal dilation, the b, or the number value of b, it will be inside but also in front of x. So make sure to distinguish between dilation and translation. Now, similar to vertical, we have horizontal stretch and horizontal compress. Now it's not the same rule, so make sure you understand the rules between vertical and horizontal stretch and compress. To classify as horizontal stretch, the value of b is going to be between 0 and 1. Whereas horizontal compress, the value of b is greater than 1. Again, if you look closely, you see how it's written as the absolute value of b. Just like before, you just want to focus on the number value if you're doing dilation. Now be aware that the value of a and the value of b for dilation, it can be written in the form of a whole number, a decimal, or a fraction. Now if it's a fraction, make sure to distinguish if it's more than 1 or less than 1. So that way you can properly or correctly identify if it's a stretch or compress. Now to go more in depth with horizontal, and it's only applied to horizontal, so this is the part where we have to be extra careful. If it's classified as a horizontal stretch, then when you write out or when you identify the transformation, you would say horizontal stretch by 1 over b. So if it's a whole number, then you simply write as a fraction 1 over b. Now, if it's a fraction already, then you would write the reciprocal of it. And I will explain and do an example of what I mean by reciprocal is if your b value was already written as a fraction. And you would do the same thing for horizontal compress. So if horizontal compress is when b is greater than 1, you simply write horizontal compress by 1 over b. And you would write that if it's a whole number. Now, if it's already in a fraction, you would write the reciprocal of it. Like I said before, you'll see when I'm going to do some example involving with horizontal dilation. So the question is, what is the difference between vertical and horizontal dilation? So horizontal, or let me go over vertical. So vertical dilation is the number outside the absolute value lines, while horizontal dilation is the number inside the absolute value lines. So again, that's the difference between vertical dilation is the number that's strictly outside, but again, in front of the function. And I keep repeating front of the function is because if you recall to translation, we had numbers that's behind the x and also behind the function. So vertical dilation is always the number that's in front and outside, whereas horizontal is the number that's inside but also in front of x. So make sure you remember the difference between vertical and horizontal dilation, and make sure to remember the rules on how to classify between vertical stretch, vertical compress, while you might have horizontal stretch or horizontal compress. Here, I wanted to go over the graphs and then compare it in terms of vertical dilation. Now, for the vertical dilation, if we look at the parent function at the top right, here's a graph of it. Now, if we were to compare it to the bottom left graph, where it's written as g of x equals 5 over 2 times absolute value of x, you can see that the number is outside in front of the function. So this is going to be vertical dilation. Now, if you look closely to the fraction, 5 over 2, that is equivalent to 2.5. So that's going to be more than 1. So this will be classified as vertical stretch. Now, if you were to compare it to the 2 graph, mainly from the x-axis, you can see that it vertically stretched away from the x-axis, or you could, in layman's terms, say that it vertically expand away from the x-axis. So now you can see how it's vertically stretched, or also known as vertically expand from the x-axis. Now let's compare it to the bottom right graph, where it's written as h of x equals 2 over 7 times the absolute value of x. Now 2 over 7, again, that's also outside the function. That's why it's going to be classified as vertical. And then 2 over 7 is equivalent to 0.285. So that means it's less than 1. So this will be classified as vertical compress. So if we were to compare it to the parent function, and in terms of the x-axis, you can see that the graph, it vertically compressed towards the x-axis, or in layman's term, you could also say vertically shrinked towards the x-axis. So now you can see how the graph, or the difference between vertical stretch and vertical compress. So for the bottom left graph, I could say graph vertically stretch away from the x-axis. Then for the bottom right graph, you could say graph vertically compress towards Let me make room. Compress towards the x-axis. Now earlier, I guess I said vertically stretch, but you can say vertically expand. And then over here, I said vertically compress. You could also say vertically shrink. So just be familiar with the different type of terms you may come across. But most of the time, I'm going to be saying vertically stretch or vertical stretch. And then I could say vertically compress or vertical compress. So make sure you know the difference. And again, I gave you the graph so that you can visually see how and why it's called vertical stretch and vertical compress. In this part, we're going to continue comparing the graphs, but this time we're going to talk about in terms of horizontal dilation. So again, I gave the parent function at the top right, but now let's compare it to the bottom left graph, where it's k of x equals the absolute value of 3/4 times x. So 3/4 is inside the absolute value and in front of x, so this is classified as horizontal dilation. Now 3/4, that is equivalent to 0.75, so it's less than 1. So we're going to classify this as horizontal stretch. So it might look confusing when you look at the graph, but if you were to look or remember that in terms of vertical, we compare it to the x-axis. So logically, we might be able to compare horizontal in terms of the y-axis. So let's take a look. So again, here's the parent function, and then here's the new function. If you look closely, you might see a little bit difference between the parent function. Now, for horizontally stretch, you can see that it is expanding or stretching away from the y-axis. Now let's look at a second graph where you can see a big distinction. So the bottom right graph, where it's m of x equals to the absolute value of 14/3 times x. Like I said before, the number is inside the absolute value and it's in front of x. So it's going to be horizontal. Now 14/3, the decimal equivalent for 14/3 is 4.67. So since it's more than 1, this will be classified as horizontal compress. Now let's compare it with horizontal stretch and horizontal compress. Now, when you're looking at the horizontal compress, or you can also say horizontal shrink, it basically horizontal compress or horizontal shrunk towards the y-axis. Whereas on the left graph, here is a horizontal stretch, or it horizontally expand from the y-axis. So these two graphs will be a good visual aid on how to see and tell the difference between horizontal stretch and horizontal compress. Now, if I were to describe the graphs in words, I would say graph horizontally stretch away from the y-axis. And then for the bottom right graph, I would say graph horizontally compress towards let me make a little bit room. So towards the y-axis. So to review, the bottom left graph The graph horizontally stretch away from the y-axis, or you could say horizontally expand from the y-axis. But I'm mostly gonna refer to horizontally stretch or horizontal stretch. Then for the bottom right graph, you can see it's graph horizontally compressed, or you can say horizontally shrunk towards the y-axis. But like I said, I'm going to be mostly using the term horizontal compress or horizontally compress. Just be familiar with all the terms because sometimes they're going to be using stretch for expand instead of stretch, and then shrink instead of compress. So we talked about the graphs. Now let's talk about the examples on how to write out horizontal dilation. Now earlier I mentioned about to be very careful when it comes to horizontal, and if you start off with a fraction, then you're going to be writing the reciprocal. So let's take a look at the first example. G of x equals the absolute value of 2 over 3 times x. So 2 over 3, again, it's inside and in front of x. 2 over 3 is equivalent to 0.67. So it's less than 1. So here we're going to classify this as horizontal stretch. So I'm going to write horizontal stretch by, so since you start off with a fraction in the problem, you're going to write the reciprocal, or basically you're going to flip the fraction. So instead of 2 over 3, I'm going to say 3 over 2. So horizontal stretch by 3 over 2. And that's all you have to do. So if you start over with a fraction, basically you flip it. So I'm going to do the same thing over here. Now in the second example, we have h of x equal the absolute value of 5 over 2 times x. So earlier I did an example with 5 over 2. That is equivalent to 2.5, meaning more than 1. So this is going to be a horizontal compress. So let me write that first. So horizontal compress by, since it's 5 over 2, when we're doing horizontal, and again, this is only for horizontal, we're going to do reciprocal of the fraction. So instead of 5 over 2, I'm going to say 2 over 5. So horizontal compress by 2 over 5. And like I said before, we do the reciprocal only for horizontal. Alright, so let's take a look at some more examples. So in the third example, we have m of x equals the absolute value of 1 over 5 times x. So 1 over 5 is equivalent to 0.20, so that's less than 1. But if you're unfamiliar with decimal values, then this is what I usually do in terms of fraction. I look at the top and compare it to the bottom. If the top is less than the bottom, then I would say less than 1. And that usually works with all fractions. So if the top is less than 1, you say that the fraction 1 over 5 is less than 1. Now if the top is more than the bottom, then you can say that the fraction is more than 1. And you can compare it to all the other fractions when you try to convert into the decimal values. Any fraction where the numerator is more than the denominator, meaning if the top is more than the bottom, then you can say the fraction is more than 1. If you'd like to add it into your notes, be my guest. That's going to be helpful. But here, the numerator is less than the denominator, so it's less than 1. So this one, since it's less than 1, I would say that it's going to be horizontal stretch. Now before I do horizontal stretch, or let me write that out first. since it's 1 over 5, if I do the reciprocal, you're basically going to write 5 over 1. So I'm not going to leave that as a fraction. You can actually simplify 5 over 1, meaning what is 5 divided by 1? It's just 5. So I'm going to say horizontal stretch by 5. So that's all I have to do. So if you have a fraction where it's a 1 on top, and when you do the reciprocal, make sure you simplify that. So if I have like 1 over 7, the reciprocal is 7 divided by 1. So again, if you start off with 1 over 7, and you're doing the reciprocal, so the reciprocal is 7 over 1, you can actually simplify that. 7 divided by 1 is 7. So again, make sure you just simplify that if you start off with a fraction similar to 1 over 5 or 1 over 7. In terms of horizontal. Now let's take a look at the next example. So in example 4, we have n of x equals the absolute value of 6x. So 6, it's a whole number, and it's more than 1. So you can definitely know that since it's more than 1, it's going to be classified as horizontal compressed. So let me write that first. Horizontal compressed. So since it's a whole number, in the beginning, if you start off with a whole number, you're simply going to write the 1 on the top and put the number at the bottom. So here, horizontal compressed by 1 over 6. So again, if it's a whole number, and if it is, then it makes your work easy. You're just simply going to put a 1 over it to make it a fraction. Now, if you were to convert 6 into a fraction, you put 1 underneath. And if you were to do the reciprocal, and again, reciprocal means you flip it. So if you were to flip 6 over 1, the reciprocal will be 1 over 6. So that's how they are similar. You got put the 1 on the top, or convert 6 into a fraction and then do the reciprocal. It's the same thing as any other whole number. If I do with 3, convert 3 into a fraction, so 3 over 1, the reciprocal will be 1 over 3. So that's what reciprocal means, is basically you flip it if you have a whole number. So again, if you start with a whole number, then it's easy. But with fractions, you gotta be careful. Make sure you do reciprocal. Again, if you're trying to determine if it's more than 1 or less than 1, as what I stated before, if the numerator is less than the denominator, less than 1. If the numerator is greater or bigger than denominator, bigger than 1.